Today we're covering section 8.4, which is about translating power functions. So first let's talk about what a translation is. That is when we take a graph and we slide it, either up, down, left, or right. When we slide it, we're not going to rotate it or make it larger or smaller. We are just sliding it up, down, left, and right. Okay, so the definition of a power function is where you have y equals a times x to the nth power. So x is our base, right? And n is the exponent. And then the coefficient is going to be a. Okay, so let's look at this example where we need to graph the function y equals x squared. The first thing we want to do is we want to set up a table, and so we can get some ordered pairs. So we're going to let x be a number, and then that way that will tell us what x squared is, which will tell us what y is. So the first number is -3, so -3 squared is 9. So our first ordered pair is -3, 9. Our second ordered pair, our second x value is -2. X squared would be 4, which means our second ordered pair would be -2, 4. And so we'll go ahead and do some more numbers. So we have a lot of ordered pairs here. Once we have a table of ordered pairs, go ahead and plot those points and connect them with a smooth curve. So we're going to go ahead and plot those points and connect with the smooth curve. So this point right here, or this curve, the shape that this makes, where it's going down and then coming back up, it's called a parabola. And that point right here where it changes direction, so it was going down and now it's going to start going up, that point is called the vertex. Right now, the vertex is the ordered pair 0, 0 because it's located at the point 0, 0. The vertex doesn't always have to be 0, 0, which we're going to see in the future. So here is y equals x squared. If I were to plot the points for y equals x squared plus 2, I would see that my graph shifts up, or it translates up 2. My vertex moved up twice. So y equals x squared minus 3. As you can see, this third equation is going to move our vertex down 3. So because of this pattern, we can now state what our translation is. So remember, our translation happens when a number is added or subtracted to the input or the output. So in this one, we kept adding or subtracting the number after the x squared, and that number was moving our parabola up and down. So for power functions, if we have y equals x squared plus k, the graph is going to shift k units vertically, so either up k units or down k units, depending on what this number is right here in the function. So we have y equals x squared. What if we put a number next to x, but before the square, before the power? So here we have x minus 2, and if we were to plot those points, we see it moves 2 to the right. If we have x plus 3 squared, we'll see that that's going to move 3 to the left. So for power functions, if we have a number next to the x, so x minus h, the graph is going to move h units horizontal, so either left h or right h. So this is the part where it gets a little confusing because you noticed that the plus 3 moved left where the minus 2 moved right. So you're going to have to watch the signs on that and know that if you're subtracting, it's going to move right, but if you're adding, it's going to move left. So let's look at a chart so that we can learn all of the translations. So if you have plus k after performing the base function, you're going to move up k units. Minus k, you're going to move down k units. If you have a plus h, you're going to go h units left, but if you have minus h, you're going to move h units right. So remember, k happens after the x squared, and then the h is going to actually happen before you square it. So let's, you can put the h and k together. So let's say you have an h and a k. That's okay. That means it's going to move h units horizontally and k units vertically. Both can happen at the same time. And what that also tells us is the vertex. Remember, the vertex was the turning point of the parabola. The vertex was no longer going to be 0, 0. It's going to be whatever your h value is and your k value. But notice that the h value is going to be the opposite sign because of the x minus h. So if you have x minus 3, then your h value is 3. But if you have h plus 3, your h value for the vertex is negative 3. So let's do some examples. We have y equals x minus 2 squared plus k. So we know that the minus 2 right there means that we're going to move right 2. And then the plus 4 at the end means we're going to move up 4. But then our vertex is going to be 2, 4. So notice the minus 2 becomes 2 for our vertex. And then the plus 4 is going to stay 4 because our k value is just whatever our k value is. Let's do another example. Y equals x plus 3 squared minus 2. So this time we're going to move left 3 because our h value is plus 3. And then our k value is minus 2, so we're going to move down 2. And our vertex is going to become minus 3, minus 2. So again, your h value was plus 3, but remember for your vertex, it's the opposite sign. So it's going to become negative 3. However, the k value doesn't change. It's going to stay negative 2. So just like the y equals x squared, we can also do y equals x cubed, and we can graph it the same way at first using ordered pairs. And when we do that, we notice that we have a point of inflection, and a point of inflection is just where the graph is going to change directions. So the point of inflection is at 0, 0. So this is what that graph looks like. And so just like with the x squared, our x cubed can also be translated using a minus h before the cubed and the plus k after the cubed. And our point of inflection, so we're not calling it a vertex anymore because it's not a parabola. Our point of inflection, or where the graph changes shape, is going to be located at h, k, where the h is going to come before the cubed and the k happens after the cubed. So again, notice that this is x minus h cubed. So again, our h value is going to be opposite of what we see here. So let's look at some examples. So compared to the graph of y equals x cubed, if we have y equals x minus 4 cubed plus 5, we're going to translate 4 units right because of the minus 4 and 5 units up because of the plus 5. Our point of inflection is going to be 4, 5 because this was minus 4, so that means positive 4, and this was plus 5, which means positive 5. Let's do another one. X plus 5 cubed minus 2 means 5 units left because of the plus 5, and 2 units down because of the minus 2 for our k value. So our point of inflection is a minus 5 because of the plus 5h, and then a negative 2 because of the minus 2k. So let's look at those graphs compared to each other. So notice this one, x cubed, the point of inflection was at 0, 0. Then we did minus 4 plus 5, so it went 4 to the right and up 5, and our point of inflection was here. And then our plus 5 minus 2, we went to the left 5 and down 2, and here's our new point of inflection. So that's how the graphs translate it.